During this experience, we will perform the Knoevenagel reaction, which involves the 4-dimethylamino-benzaldehyde, the cyanoacetic acid, and the piperidine as catalyst to obtain a merocyanine dye. In order to perform the reaction, we need some apparatus and glassware. A lift to raise up and down the heating stirrer, the stirrer obviously, a flask and stir bar to perform the reaction, to contain the reaction, a condenser, a thermometer, and the tubes for cooling water. Just at the beginning, we take our flask, we put the stir bar inside, and we have to attach it firmly with the clamps. After, we take the condenser, we put it into the flask just to fit into it, and fix it clearly with the clamps. Once the apparatus is okay, we have to put tubes in the both ending of the condenser, starting from the bottom, which will be the inlet of water, and putting after from the top a tube. The water source is connected to the tube that stays at the bottom of the condenser. The tube that comes from the top is inserted into the sink to drain water. Since the reaction needs to be performed for a long time, we have to keep firmly attached the tubes by using hose clamps. So those hose clamps are connected, tightened firmly, and after we will cut them. Just after, we have to fasten a hose clamp also to the tube that is connected to the water source, so we will be sure that we will not have any problem during the night. Now we have to start weighing operation. We will start with the 4-dimethylamino benzaldehyde, which will be weighed very carefully. Making obviously a tear of the balance. After, we have to wait our cyanoacetic acid. After having weighed our samples, we can add the solids into the flask. We use an oily paper used normally for weighing samples that can help us to add all the solids inside without having any problem of leaving materials on the neck. First we add the benzaldehyde. Any kind of residue material can be transferred if any, so be careful. And after we add the cyanoacetic acid the same way. If some residue is present, you can help you with the spatula. Now we can add the solvent, in this case 15 milliliters, so we can add twice with the help of a cylinder of 10 milliliters. Now it's time to close our apparatus. We can bring our condenser just in line vertical to our flask. We can put some grease in on the male joint to help you to fit and to seal the joint. After, simply we have to let the condenser to go down and rotate it for a while to make the grease to seal perfectly the system. So now we can let flow the cooling water through the condenser by opening the tap and letting the water flowing from the bottom, opening this system and introducing the catalyst, which is the piperidine. We add just a few drops, 3-4 drops. And after we close the system. We can now start the reaction by putting some oil bath to be able to heat the system conveniently. We place tubes away from the stirrer so that they cannot be affected by the heat and burnt. After, we can lift up the stirrer, place correctly the system in order to be able to stir well, and we can switch on, make a trial for the stirring, and after we can start heating. So now, before heating the reaction, we place a clamp so that we can put into it our thermometer that will touch the oil, so being able to reveal the temperature of the oil and consequently the temperature of the reaction. When all things are okay, we can start heating the system and the reaction will start. When the temperature is reached, some drops of solvent condensed into the condenser will drop from the top. Here we can appreciate that the temperature reached about 90 degrees. After 6 hours of reaction, we can see that first solid appears and they can be found as spots, orange spots onto the flask. Here we can see them better. After 1 day, the reaction can be stopped and left to come to room temperature. It is evident from the color that we have a precipitation of the material. We can remove and clean the thermometer. We use the lift to remove the contact between the oil bath and the reaction flask. We can remove also the condenser. And after, we can remove the flask from the clamp. We can clean it with a piece of paper from the oil. And finally, we will put onto a suberate ring. Now we are ready for filtering. We can prepare the filter flask with the Hirsch funnel by putting also a filter paper, opening the pump and connecting it to the flask, to the receiving flask. After, we can take a bit of ethanol to wet the filter paper so that it can adhere perfectly to the ceramic filter. This is called the Hirsch filter. After, we have to suspend with the spatula and keep suspended our solid so we can be able to filter nearly in only one step. Sometimes we can also help us with the spatula to remove last portions of solid and let them to be filtered. Now we can appreciate the orange color needle that we obtained. Checking the solid weight, we could see that we obtained more or less 0.21 grams, which is 40% yield. Now we are ready for the TLC analysis. We cut a layer of the silica and we make a deposition of the three compounds at about 1 centimeter from the bottom. The first one is the dimethylamino which is a standard starting material. The second one is the solution of our compound, and after we will deposit the reaction solution, which was coming from the filtration of the solid material, and which will contain for sure some of the starting material. Before eluting the TLC, we can appreciate where we have deposited the different compounds under the illumination by UV light. We prepare a container with the element, which can be a mixture of solvent, and we introduce into it the TLC. After, we close to maintain constant the atmosphere inside the chamber. Now we can see the process of capillarity that brings on the solvent to run over the TLC. This process is now accelerated, so it normally takes from 5 to 20 minutes depending on the solvent. Sometimes it takes also more. In this case, about 10 minutes. When the TSE is sufficiently developed, we can extract from the chamber and mark the front of the solvent. It will be used to determine the retardation factor. We can see that the final solid product is stuck on the bottom due to the interaction of carboxylic group with the silica and is marked with a green arrow, and it is pure. The solution instead contains still a bit of aldehyde. So we have finished. Thanks for watching.